Hi guys, welcome back to the channel. Today we're going to take a look at the best ways to store images in your app. We're going to look at some existing methods that large-scale companies like Google and Facebook use, and how you can use something similar to store images in different apps that you design. So looking at some data from 2021, currently Facebook stores over 260 billion images. That's around 20 petabytes worth of data. Google stores over 4 trillion images. So most of the popular apps nowadays like Facebook, Google, Pinterest, Yelp, Twitter ends up storing lots and lots of images. So they need a very sustainable way to store and serve these large amount of data. So let's look at the first way you can store images in your backend. So the most basic way you can do it is just store the raw binary data in your table. So what you could do is just let your client take in the photo, and then you pass the photo to your backend. And in the backend, you convert it to a binary data object, which you can do very, very easily. And then you store the whole data blob in your database table. So from the example table I have over here, you can see the table has ID, name, age, and the avatar of that user. And for the avatar, as you can see, we're just storing the whole data object within the table. So this is very easy to implement. That's why I have it as the first approach, which is the most basic one. The pros of an approach like this is it's super straightforward and easy to implement. But unfortunately, that's where the pros end pretty much. This approach, even though it's the most simple, comes with the most number of problems. So the first problem is doing things this way. Your query latency is going to increase by a lot. That's because every row in your table has one column, which is the whole data object. So that is going to be significantly larger than like typical text data or number data. So every time you look at a row, your query is going to take longer because it needs to retrieve the whole image data blob from the database, which is very expensive. Also, doing it this way means that you're going to be using more network bandwidth. So let's say your front end requests the user object. The user object includes the ID, name, and the data. And if you store the whole image as a data file in your table, that would mean when you're sending the data to the front end, you send the whole image back to the front end with every call. And of course, image being much more image requires much more space than text data. So every time you send data to the front end, your network calls are going to be much more expensive. Similarly, your database is going to use lots of memory, because now instead of only storing text data or numbers, you're storing data objects and images. Especially images nowadays tend to be huge. Like you can get images of like 4 or 5 megabytes. And if you store that in your database, of course, your database will end up using much more space than it would if you did not store it in the database. The system does not scale well. This is pretty much a combination of the other 3 reasons above. Firstly, you have your database increasing in space very, very quickly, because with every user, you're adding like 4 to 5 megabytes worth of data, because the image itself is like 4 to 5 megabytes. And in terms of network bandwidth too, if you have more and more users coming to your app, each of your network call is going to become more and more expensive. And same goes for the query latency. So overall, as your app scales, this system becomes the bottleneck where all the problems are going to start happening. The other one I have here is doing it this way, you cannot support multiple sizes of the image easily. Nowadays, it's very common to have different sizes of the image so that you can serve the same image in mobile, tablet, TV, and laptops in different sizes to make things more appealing to look at. And if you're storing the whole image as a data blob, it's very difficult for you to resize the image for these different screen sizes. And lastly, storing the data object in your database makes it very difficult for you to utilize CDN. I'm going to come back to what CDN is and how we use them in the later slides. But for now, all you need to know is if you store the image as a data blob in your database table, then you cannot use CDNs, which becomes a big problem as your app is scaling. All right, so let's look at a slightly better approach. We're going to call it the local file system. That's approach 2. The way this approach works is you store the image files locally in your server. So you don't turn it into a data object and put it in the database. Instead, let's say you get a JPEG file from the front end. You get that in your backend, and you just store the image in a directory just as a JPEG file. So instead of converting it to binary data, you're just keeping a JPEG file in your server. And in the database table, you can see we have the same table, but the avatar column is the directory of the image. So it's literally the local path where you stored the image. So in this case, let's say we have a cat.jpg. So you're just going to put it in your images directory in the local machine. So this way your table is not using too much data because it's just storing that string URL, and it's your local machine that's actually storing the JPEG image. So there are a few pros with this approach. The first one is, of course, the less storage used. So your database table over here is going to use less storage because instead of storing the whole data blob, you're only storing the path URL, which is essentially a string. So it's going to be significantly cheaper. Also, given you're not turning your image into a data blob back and forth, you won't have a lot of image compression issues because you're pretty much taking the JPEG from the client and then just storing it in your local machine as a JPEG. So you don't have to worry about weird compression issues. However, there are a bunch of cons with this approach too. The first one is you are storing these images locally in your file system. So you would need to somehow serve these images to the client from your local machine. So somehow you need to either write some firewall rules or do something fancy so that an outside world can talk to your directory and get these images, which comes with security implications too. So this is not something that people tend to use. The more obvious issue is that it cannot scale to multiple servers. Let's say right now you have one machine only, and you're storing all these images in your one machine. However, the way it works nowadays, your backend tends to scale up and down. So at any point in time, you can have 100 instances, or you can have 5 to 10 instances. Regardless, the problem is as you scale up or down, you would either have to duplicate the images in every single machine, which becomes very difficult to do, or somehow you need to use some proxy server where you store all the images, which again gets very, very messy. And lastly, similar to the other approach one, you cannot use CDN very easily with this approach, which becomes a problem too as you scale your app. All right, so now we're going to go to the most optimal solution, which is pretty much the industry practice right now, and most big companies end up using this. That is use distributed object storage like AWS S3. There are a bunch of other object storages that people use, but S3 is the most popular one right now. So we're going to use S3 as the example. So let's see how S3 fits into this new optimum solution. So if you look at the image from left to right. To the left, we have our client. In the client, the user uploads the photo, so it's just going to be the user maybe in their browser, hitting a button, and then choosing a file from their local computer. And then the file is passed to our backend server. At this point in the backend server, we're going to take the JPEG file and then store it in AWS S3. You can do it through a pretty simple API request where you give S3 your JPEG object and it just stores it as is. And then when S3 stores your image, it's going to give you a URL. You can use this URL to access the image. So we take this URL and store it in our metadata database. So if you take a look at an example over here, it's very similar to the previous approach, but here in our avatar column, the URL we have is an S3 URL. The way the S3 URL works is you can access it from any machine. So in the previous approach, what we had was the URL was specific to your local machine. So as you scaled up and down, it was becoming very hard for you to use this local file storage. However, with the AWS S3, it's a distributed file storage. So no matter how many servers you have running, you should always be able to access this S3 file, both from your backend and front end. So just to sum up, what we're doing over here is you have the client passing the image to the server. The server takes the image, puts it to S3. S3 gives the server a URL back, and then we store the URL in our metadata table so that we know where to go find the avatar for every user. Let's look at the pros associated with this approach. The first one is it can support multiple image sizes. So when you're uploading the image to S3, you can upload 3 or 4 different sizes, and maybe you have the same name, but at the end of the URL, you add the size. So if it's large, you can do large.jpg or small.jpg. So it becomes very easy for you to support multiple sizes. Your database uses less storage because instead of storing the whole data blob, you're just storing one URL, which is much more efficient. It scales very well because your server can scale up and down independently. It doesn't have to worry about storing images in the local machine. The queries are going to be faster because when you're querying the database, your database is smaller overall, which means the queries are going to be faster. And AWS S3 has a very easy integration with a lot of CDNs like Cloudflare and Akamai and a few others. So we're going to take a look at a later slide how you can integrate CDN very easily if you're storing your images in S3. There are a bunch of problems associated with this approach too. The first is, given you have to maintain S3 now, you have to set it up, which requires setting up an AWS account, doing a bunch of integrations, so that is some overhead you have to go through. You have more things to maintain. Now that you have S3, that's another system to maintain, which can get more expensive. And in terms of expensive, S3 has its own cost. You have to pay for it, so that adds on to your expenses. And there can be possible network failures when you're trying to upload a photo to S3 or get a photo from S3. Because unlike your local machine, this time you are trying to set things or get things from across the network, which can always fail. All right, so that was the most optimal solution. Now we're gonna add one final piece to it, which is gonna be the CDN. And where does the CDN fit in? So just to take a look at the system we already built so far, we have our client to the left. The user uploads the photo on the client, and then it gets passed to our backend server. From our backend server, we are sending the image to S3. S3 stores the image and then gives you back a URL, and then you store the URL in your database table. So now let's see where does CDN fit in. So as you can see, top right, CDN fits in right next to your AWS S3. So the way you can configure S3 is you can give it a CDN to use, so that instead of storing the images only in the AWS machines, it also stores it in the CDNs. We're going to take a look at how CDNs work, but that's where CDN fits in to this architecture. So now what happens is when S3 gives you the URL back, instead of giving back an S3 URL, it gives back to you a CDN URL, which you can use just like any other URL, but this gives you a bunch of advantages. So just by adding that one CDN, you make things much more performant, and you really don't have much overhead on your backend. All you have to do is integrate your CDN with S3, and S3 has a bunch of automatic integrations that it can do, so you don't really have to set it up too much. Alright, so that brings the question, what CDN and why use CDN? So CDN is pretty much sort of like a network caching layer. So you can cache most of your popular images on the CDN. So what happens is when these images are being requested, instead of serving them from your S3, the S3 data store, you serve it from servers that are closest to the user. So let's go through an example to make more sense of it. So let's say all your backend servers are in North America. Your S3 clusters that you have are also in North America. Now let's say you have a user who lives in Asia. So in a world without any CDN, when the user requests the image needs to travel from North America all the way to Asia. So that's a long trip that the image has to make before the user can actually see the image. So of course that means more latency, more chances of failure, and overall just not a very good user experience. Now in a world with CDNs, what's going to happen is your CDN client, so whether you use Cloudflare, Akamai, or some other ones, they have machines all over the world. Let's say they will have machines in Europe, Asia, South America, North America, all the places, right? And when you're caching the images in these CDNs, you have a copy of the same image in all the different machines all over the world. So when a user from Asia is requesting a particular image, instead of the image needing to travel all the way from North America to Asia, the image will be served from this CDN within Asia. So of course it's going to be much faster. It's going to be there's going to be less chance of failure, and overall it's going to be a much better user experience. And you're getting all these benefits just by integrating AWS S3 with your CDN, which is very quick. Alright, so that is the final solution that we have over here. So I'm just going to go over it one last time, and then we're going to end the video. So from left to right, we have our client where the user uploads the photo. Let's say it's a JPEG file. The JPEG file gets sent to our backend server. From the backend server, we send a request to S3. What S3 does is stores the photo and works with the CDN, Cloudflare, or Akamai to decide whether to put the photo in the cache or not. If it's a photo that is going to be accessed very frequently, it's going to put it in the cache. And then once it puts it in the CDN, it's going to give your backend a CDN URL back. You're going to store this URL in your database table. Now, when a different client wants to see their avatar, what's going to happen is the browser is going to get that CDN URL from your backend, and then it's going to use the CDN URL to get the image, and your CDN provider, whether Cloudflare or Akamai, can look at this CDN, can see where your user is staying, and based on your user's location, serve the image from the closest machine. So it's much more performant and a much better user experience. So that pretty much sums up the design I wanted to come up with today. So this is pretty common in today's world, and most companies use a structure and architecture like this. So I think it's a very nice thing to know. So with that being said, hopefully this was helpful. Put in the comments if you have any questions or concerns, and I'll get back to you as soon as I can. And I will catch you all in the next one. Bye-bye.